Hello, welcome to my atomic structure past paper question video. So, you should know the drill by now if you've already had a look at my past paper question videos. I have the past paper questions on the screen, you read them and do the questions, and then you unpause the video and look at the answers. So, we're going to read this first question. Lithium was discovered in 1817 by the Swedish chemist Arfvedson. Lithium exists naturally as a mixture of isotopes. Explain the term isotopes. Which isotope is used as the standard against which relative masses are measured? The mass spectrum below shows the isotopes present in the sample of lithium. Use the mass spectrum to help you complete the table for each lithium isotope in the sample. And you have a percentage composition table to fill in. Calculate the relative atomic mass of the lithium sample, and the answer should be given to 3 significant figures. So I'll pause for 5 seconds and we'll go through the answers. Okay, so isotopes are an atom with the same number of protons and electrons but a different number of neutrons. And the isotope that is used as a standard against which relative atomic masses are measured is carbon-12. And the percentage composition is very hard to tell from this graph, but if you look at the isotopic mass of 6, that should be 8, as each gradient is 10 on the graph. So we're going to have an educated guess and write 8 down. For the relative isotopic mass of 7, it would be 92%. And put percentage with the sign for the other one. So number of protons for lithium. Look at the periodic table for number of protons for lithium, as it's not going to change for any other isotope of lithium. So both of these are 3 protons, and the number of neutrons for lithium 6 is 3, and the number of neutrons for lithium 7, which is the standard one, is 4. So you get a mark for each column of the table correct. So you need to get 8% and 92%, both of them for 1 mark, and both of these for the other 2 marks. So the next step is to calculate the relative atomic mass of the lithium sample, and the answer should be given to 3 significant figures. So the way to do this is to let the calculation like this, and then times it by the molecular mass, and then you add that. So I haven't got much space, I'm just going to simplify. That's 92 over 100, and then that should come out as 6.92. Now atomic mass has no units, so you put 6.92 and just that. So the next question now. The 50p coin contains nickel alloyed with metal A, and nickel exists as a mixture of 3 isotopes, nickel 58, 60 and 62. You need to complete the table, standard jobby here, and metal A can be identified from its relative atomic mass. The analysis of a 50p coin showed that 2 isotopes of metal A were present in the following percentage abundances. These abundances are in the second row of the table for some peculiar reason, but they're 77.2 and 22.8, and the isotopic masses are 63 and 65. So what they actually want to ask you is, what is an analytical method used to obtain the information, and what is the term relative atomic mass? And if we look on the next part of the question, we need to calculate the relative atomic mass of the sample of metal A, and we need to give the answer to 3 significant figures. We need to find the identity using a yellow datasheet that you can download off the internet, or you should get paper copies from your lecturer. If you do not have one, then go get one. And this part of the question I will come back to in a bit, as it is a completely standalone part of the question. So I will pause and you can have a go at the question. Okay, so for the proton, neutrons, and electron numbers, protons and electrons will be exactly the same no matter what isotope you are using. So every single isotope should have 28 protons and 28 electrons. Now, working out the number of neutrons is taking away the proton number away from the actual mass of 58, 60 and 62. So we get 32 and 34. And the analytical method used to obtain the information is mass spectrometry. And the term relative atomic mass is the weighted mean mass of an atom when compared to 1/12 of the mass of an atom of carbon-12. Weighted mean, one more, weighted mass of an atom. The weighted mean mass of an atom is 1 mark when compared to 1/12 of the mass, another mark, of an atom of carbon-12, another mark. So learn your damn definition and you will get those 3 marks. Anything that is not those words may not be accepted, so do not try and put it in your own words unless you want to, unless you're really good at putting it in your own words and you get all the marks. But just make your life easy and learn this definition here. So for this part, calculating the relative atomic mass of the sample of metal A. Same job again, so we have 77.2% over 100 times by 63 plus 64 times 22.8 all over 100. Now, actually, the way I'm doing, reason why I'm doing it two different ways around, is because it doesn't matter which way you want to do it, you'll still get the same numbers go away, and then that number will be 95.228. Since they want our answer to 3 significant figures or 1 decimal place, 95.2 is our answer. And our unidentified metal is MO, or molybdenum. I cannot pronounce that, but it's on the table, and it's closest to the number we have found. And this one, nickel, makes up 25% of the total mass of a 50p coin. A 50p coin has a mass of 8 grams. Calculate how many moles of nickel atoms are in a 50p coin, and then you have to use this number here to calculate the number of atoms of nickel in a 50p coin. So I'll give you a quick pause, and off we go again. So working out 25% of 8, it's quite easy, it's 2. So then we find the mass of nickel on the periodic table, and that is 58.7. And you should get 0.03407 ... which is about 0.034 moles. So that's your answer down there. And then all you have to do is times the number of moles. Use your full calculator display from the previous answer, not the rounded one, to get the most accurate number of atoms. And this number is the Avogadro's constant. I hope you remember that. So the answer is 2.0511 times 10 to the 22 atoms. So that answer goes in that answer line there, and that's a mark, and that is 2 marks for realising that 25% of 8 is 2, and then working out the moles. This one is just timesing that number by this number, and then getting another number. So that's it in terms of old spec questions for the atomic structure. I hope you found this video useful. I have the question sheets on the video description, so if you want to have another go down to the description and check out the Google Drive link that I left in the description. Thank you and goodbye.